Imagine this, a quiet bathroom in ancient Greece. A tired mathematician lowers himself into a tub of water. As he sinks in, water spills over the edge. He freezes. His eyes widen, and suddenly, bathwater becomes the key to solving a royal mystery. How could something as ordinary as overflowing water expose a fraud and change science forever? More than 2,200 years ago, in the Greek city of Syracuse, lived a brilliant thinker named Archimedes. He wasn't just a mathematician, he was an inventor, an engineer, and one of the greatest scientific minds of the ancient world. At that time, Syracuse was ruled by King Hiero II, and the king had a problem. He had commissioned a magnificent crown made of pure gold. He supplied the gold himself, but when the beautiful wreath was finished, he had a suspicion. What if the goldsmith had cheated? What if he'd mixed in cheaper silver and pocketed some of the gold? The crown weighed the same as the gold the king had provided, but that didn't prove it was pure. And here was the catch. The king did not want his beautiful crown damaged. He needed the truth without destroying the evidence. So he turned to Archimedes. Imagine the pressure. Archimedes had to figure out if the crown was pure gold, without cutting it, without melting it, without breaking it. Now, gold is much denser than silver, meaning a lump of gold takes up less space than a lump of silver of the same weight. But how could he measure the volume of an irregular, twisted crown with no modern tools? Just a mind searching for an answer. And then came the bath. According to the ancient writer Vitruvius, Archimedes was stepping into a public bath when he noticed something simple, yet extraordinary. As he lowered his body into the water, water spilled over the edge. The more of his body that went in, the more water overflowed. In that moment, he understood an object placed in water pushes water out of the way. The amount of water it displaces is equal to the space the object takes up. It doesn't matter what shape the object is. What matters is its volume. He had it. He could measure the volume of the crown by placing it in water. Then he could compare how much water it displaced to the amount displaced by a lump of pure gold of the same weight. If the crown pushed out more water, it meant it took up more space. If it took up more space, it was less dense. And if it was less dense, it wasn't pure gold. The bathwater had revealed the hidden truth. This idea is what we now call Archimedes' principle. Simply put, when an object enters water, it experiences an upward push called buoyancy. You've felt this when you try to push a beach ball underwater. It's what makes massive steel ships float. Their shape displaces enough water to create a buoyant force strong enough to hold them up. Archimedes was one of the first to clearly understand and describe this invisible force. So, what about the famous story? Did Archimedes really leap from the bath and run naked through the streets shouting Eureka, which means I have found it? In Greek, well, the story was written centuries after his death, so it might be a bit exaggerated. But the excitement, that feels real. Anyone who has struggled with a problem knows that incredible rush when confusion suddenly turns into clarity. Whether he ran naked or not, the discovery was revolutionary. This wasn't just about a crown. It was about discovering a universal law of nature through observation and reasoning. His work laid the foundations for physics and engineering. Today, his principle helps us design ships, submarines, and even hot air balloons. From an ancient bath to modern technology, the idea still holds true. In the end, Archimedes' story reminds us that great discoveries don't always happen in fancy labs. Sometimes they happen in ordinary places, during quiet moments. A bathtub, a curious mind, and water spilling over the edge. Sometimes the world reveals its greatest secrets to those who are simply paying attention. Thanks for watching. If you enjoyed this story, don't forget to like and subscribe for more.